Hello and welcome to another segment of Geology Hikes with Thomas. Today's topic is laccolith. Before I explain what a laccolith is, let's just enjoy the view from here high up at the Tuckerville communication towers across the valley where I-15 goes from Las Vegas to the left to Salt Lake City to the right. And in the background, we have a tall mountain range up to 11,000 feet high, the Pine Valley Mountain. And the top of this range is a laccolith. A laccolith is formed by extruded igneous rock. The liquid igneous rock is pushed upwards from the magma chamber. But instead of punching through the surface and forming a nice volcano, it finds a weak spot between rock layers, like rock layers, sedimentary rock layers, and starts spreading sideways, lifting up the rock layers above it, and forming eventually a nice big pancake. In our case, the Pine Valley Mountain Laccolith is the largest laccolith so far described. It was formed about 20 to 22 million years ago. It covers an area for 600 square kilometers and is over 900 meters thick. So it's quite a big pancake. The rock is rhyolite. Rhyolite is the extruded form of granite. We see some small hills down close to I-15. That is also part of this laccolith. How it ended up here, we don't know. But it's convenient for us because it provides easy access to study a laccolith. So let's go down there and start looking around. The goal is really to maybe find an interface between the igneous rock and the sedimentary rock. We reach the foot of the mini laccolith. On top we can see rhyolite, grayish, and below sediment, yellow and red. So there must be an interface here. Now, just a warning, looking at the geological map, it indicates that's not an interface between igneous and sedimentary rock, but a fault. So at least you can see both formations, the sedimentary, red, yellowish, the grayish, igneous, rhyolite next to each other. Look at the Claren formation here. It clearly has been altered by the heat. A lot of it is crumbly. No solid rock bands are visible. Now starts the traction part. Let's continue the interface and see if there's some more interesting features here. Well, it's kind of easy to follow the interface. Just make sure that the red rocks are on your right and the grayish blackish rocks are on your left. Looks like we're still on the right track. The Claren formation is kind of fading in and out here, so I'm just traversing here a stretch of Claren, and if you cross over you'll end up in the monzonite zone. I see some monzonite picking up here, plenty of, so yeah. Always a step at a time, and walking sticks are really helpful here. It's easy to go downhill involuntarily. Now we're back onto the monzonite, the way it looks, yeah. Huh. Look at this. Find of the day. Poor geologist lost his hammer. Well, let's pick it up. Don't leave any garbage. Here it is, it's a nice hammer. Oh, if knowing that, I would have taken mine along, but this is kind of beaten up here. Okay. Nice rounded quartzite. We have colorful ones. And of course, quartzite is a sediment, so it's no surprise it's being banded once in a while. But what hit me now is, if I look here, look at this guy here. It looks completely different outside and inside. That could be one of those partially heat metamorphic rocks as well. And if you look up here, still more rocks. You just seem to see the same thing again. A core in the quartzite that looks completely different from the outside. Well, let's see if we can pick one up. Well, I dug it out. It looks pretty big, but it's not too big to carry, I guess, if you're desperate. Again, two nice specimens from partially heat metamorphized quartzite. Up on this beautiful exposure of the Hurricane Fault, Hurricane Cliff, the Fault Scarp. Here again the Permian rock, 270 plus million years old, and here about 400 meters or 1200 feet high. Well, as nice the view is up here, we need to find a way down there. Just about here. That's our next stop. Okay, let's get going. As we get lower and lower here, we're leaving the grayish monzonite / rhyolite section, and here we're ending up in the red Claren formation again. So this is interface on the other side. Again, beautiful view, just nice Sunday afternoon here, pretty quiet except for a couple of airplanes, people doing Sunday tours, but otherwise just lovely place to be. Here looks like I have a drop. Well, let's figure out how to get around it. Nothing on the left side here, but there must be a way because I've been down here before. Well, let's just enjoy the view here. Look at this. Old Claren formation down here. Now to right, a little hill there. That's actually Jurassic. That's Navajo sandstone or whatever is left of it after all the erosion here. Okay, so let me put the camera away and find a way down out of this maze here. As I climb down the hillside, here we have again the Laccolith, monzonite, rhyolite, and I'm going down this little creek bed, and look and behold, there's a transition between the two rock faces. Never seen that before. That's pretty cool. Here we have rock-to-rock contact between the rhyolite on top and the mudstone Claren formation below. Rhyolite 20 to 22 million years old, Claren formation about 60 million years old. I've moved a little further down this interface, come to a place where the red Claren formation is on the side of the slope, not in the center of the creek here, or of the drainage. Digging a little deeper, and it's very clear. The igneous rock goes lower and lower, and the red sedimentary mudstone seems to be disappearing. So this interface is clearly at an incline, and it roughly corresponds to the incline of the sedimentary layers in the area altogether. So, cool afternoon. Well, I hope you enjoyed today's hike. Was a little wilder than other ones, but I hope you will be back, and thanks you for watching. See you next time. Take care.